Alright, this is a review from most, 4.1 and 4.2. It's all review of graphing. So the basic graphing ones, I guess I would remind you that you're going to have to do without your graphing calculator. So first and foremost, make sure you have the forms down. So note here I have the 3 different forms, and I want to make sure that you recognize them well and have them memorized. So if you don't, that would be your first task before you take the test, and that's right around the corner. So the first one, part A, of course that's intercept form, and it gives you the x-intercepts, and the B is your good old standard form, and that means part C is your vertex form. And we'll talk about what each form utilizes. I'm going to start with standard form. Okay, so y equals ax squared plus bx plus c. Make sure that you know the formula to find the x-coordinate of the vertex, which is the opposite of b divided by 2a. And then the problem on the exam is going to look exactly like the following. So again, pause the video, make sure you can find all the pieces that you're prompted for and that you can graph it, and then I'll go through it quickly. So y equals 2x squared plus 8x plus 14. First thing you're going to be asked to find, of course, is the vertex. So because it's in standard form, I can use the opposite of b divided by 2a to find the x-coordinate. Well, the opposite of b is going to be a negative 8, and 2 times a is 2, so that's going to be negative 8 divided by 4, which is negative 2, so that's the x-coordinate of my vertex. And then to find the y-coordinate of my vertex, I'm going to plug in my x for all of the x's and simplify that to see what I get for y. And I'm just going to talk through this. So negative 2 squared is positive 4. 2 times positive 4 is 8. 8 times negative 2 is negative 16, and then plus 14. So then, of course, 8 minus 16 is negative 8. Negative 8 plus 14 is 6. So negative 2, 6 is my vertex. Now, the axis of symmetry is always the x-coordinate of your vertex, so you need to know that, of course. So that would be negative 2, and it's an equation, so don't just write negative 2. It's x equals negative 2. So I kind of know that dashed line over here at x equals, except I didn't put it at negative 2, sorry. So x equals negative 2. Let's try that again. There we go. There's that axis of symmetry. Pattern of change, remind yourself, is always a times 1, 3, 5. So my a is 2. So 2 times all of those will give me 2, 6, and 10. And the y-intercept, of course, is if you plug 0 in for, all of the x's of the equation, and I probably don't have to write that out. That's pretty easy, so that's going to wipe out. So the y-intercept is actually going to be at 0, 14, which I don't have enough room on my graph to show that, but that's okay. So I kind of picked a bad graph here, but we'll make it work here. So I'm actually going to blow up. So my vertex is at negative 2 and 6. So if I go over to negative 2, 6, there's my vertex right there. And I would then plot my pattern of change, which is over 1 up 2. So from here, and I'm not going to actually draw it in because I have too much writing. I apologize for that, but I think you're going to be okay. So over 1 up 2, and the other direction over 1 up 2, and I can kind of sketch that in, of course. So right here and right here. And then from these points, I'd go over 1 again, up 6, my pattern of change, over 1 up 6, and you get the idea. So it's going to be kind of a parabola like that. Sorry about my graph again. All right, the second equation, pause this video, see if you can recognize the form and answer all of these questions. So this one is in vertex form, and I know that because of the quantity squared. So the vertex, that means, is quite simple, is hk. So h is always the opposite sign, so that's a negative 2, k is 1. And the axis of symmetry is x equals always the x-coordinate of my vertex. Pattern of change is a times 135, so a is negative 1. See that right there? So it's going to be negative 1, negative 3, and negative 5. And the y-intercept means plug 0 in for x, which actually takes a little bit of work. So 0 plus 2 is 2, and 2 squared is 4. That's really negative 4 plus 1, which is negative 3. So my y-intercept is 0, negative 3. So my vertex is at negative 2, 1, which is right here. And my pattern of change is over 1, down 1, over 1, down 3, and over 1, down 5, which will take me just a little off the graph. And then go in the other direction, over 1, down 1, over 1, down 3, and to the left 1, down 5. And double check my y-intercept should be at 0, negative 3, and certainly it is. And of course connect your points, and there's your parabola in vertex form. Alright, last but not least, good old x-intercept form, the one that some struggle with more often, so again, pause the video, see how well you do. Some really just have the desire to FOIL this out and put it into standard form, which is fine, totally up to you. But you know, if you make a mistake putting it in standard form, then everything's going to be wrong. Not to mention that intercept form actually is quite simple. So when it's an intercept form, that identifies your intercepts, and remember that they're both opposite signs. So my, oh, I didn't even put a blank here, sorry. My x-intercepts are going to be at positive 1 and negative 3. And I'm going to plot those. Positive 1 and negative 3 are going to be my x-intercepts. Well, my vertex, this parabola is going to open up, and I know that because a is positive. So if my parabola is going to open up, I know my x-coordinate on my vertex has to be halfway in between that because of the symmetry of a parabola. So what's halfway in between 1 and negative 3? Well, obviously negative 1. Now, if it weren't clear, visually clear, take your x-intercepts and add them together and average them, and of course you see that that is negative 1. So the x-coordinate of my vertex is negative 1. Then I'm going to plug negative 1 in for the x of my equation to find the y-coordinate, and do a little math here. So negative 1 minus 1 is negative 2. Negative 1 plus 3 is positive 2. 2 times negative 2 is negative 4. Negative 4 times 2 is negative 8. So negative 1 and negative 8 is my vertex. Axis of symmetry, again, always the x-coordinate of my vertex. Pattern of change is a times 135, so that's going to be 2, 6, 10. And my y-intercept, if I plug in, I'll go down here, 0 for all of the x's, and do a little bit of math. So 0 minus 1 is negative 1, 0 plus 3 is 3, that would give me negative 6, so my y-intercept is 0, negative 6. So I know my vertex is negative 1 and negative 8, and I'm just going to estimate negative 8 is a little bit off my graph, and that's fine. And now really I have enough. If you wanted to check your pattern of change, you certainly could. So from my vertex, I'd go over 1, up 2. I'll make a dot there. Over 1, up 1, 2, 3, 4, 5, 6. Well, I fall right on my x-intercept, so that's good. If I go the other direction, over 1, up 2. And, you know, if you want to fill in those points, you certainly can, but really, once you have the x-intercepts and the vertex, that's enough to get the rest of your parabola.